Every time you ask a chatbot a question, or generate an image, or even just get a movie recommendation, you're tapping into something absolutely massive. There's this hidden world of machinery that's driving a revolution on the scale of the steam engine. Today, we're going to pull back the curtain and look at the real engine of AI.
Right. So think about it like this. Every single one of those AI interactions relies on a kind of digital factory. But what's actually inside one of these things? I can tell you it's not just a bunch of servers in a dusty room. No, it's something way more powerful and a whole lot more demanding. We are officially entering the era of the AI factory. And look, that isn't just a cool metaphor, it's a fundamental shift in how we build our digital world. From the cloud that we can't see to the very real concrete buildings that house it all, a new industrial revolution is absolutely underway. So, what is an AI factory exactly? Well, it's a completely new breed of data center. It's purpose-built right from the ground up to handle the colossal power and, as we'll see, the crazy cooling demands you need to train and run these massive AI models. You should think of it less like a quiet library for data and more like a supercharged foundry where intelligence itself is being forged. But, building these factories, it presents a massive, massive challenge. This isn't just about plugging in a few more servers and calling it a day. Oh, no. This is a completely different engineering game with a whole new set of rules. To really get it, you have to compare the old world with the new. See, traditional data centers, they had pretty predictable, steady power loads. They were mostly just air-cooled. But these new AI factories, they have extreme power density and these wild, fluctuating energy needs. I heard one engineer describe the power load as going from basically a short circuit to an open connection in an instant. That requires you to totally rethink the entire system, especially how you get rid of all the heat. And that brings us to our first really mind-boggling number, 80 times. An AI-ready server rack can have 80 times the power density of a traditional one. Just let that sink in. We are packing an absolutely incredible amount of computational power into the exact same physical space. And all of that density, it really adds up. A single large-scale AI data center could eventually consume up to 1 gigawatt of power. To put that in perspective, that's enough energy to power a small city. We're not just building data centers anymore, we're basically building power plants that can think. And of course, all of that power has to go somewhere, right? Jordan Tinnemeyer from AWS puts it perfectly here. He says, we take an enormous amount of electricity and we convert this into heat, and we have to extract this as efficiently, as effectively as possible. Power in creates heat out. It's a simple law of physics, and solving that heat problem, that's the next great engineering puzzle of our time. So how on earth do you solve for these just unprecedented levels of heat and power? Well, the answer lies in some pretty incredible new engineering innovations that are making these factories of the future actually possible. The problem, at its core, is that air just can't move heat away fast enough anymore. Think about it. You're at the beach on a hot day, say 30 degrees Celsius. The air feels warm, right? But if you step into water that's also 30 degrees Celsius, you feel instantly cooler. That's because water is just way, way more effective at absorbing heat. And that's exactly why the whole industry is making a huge shift from air to liquid cooling. And this just gives you a little taste of the toolkit that's being built for this new era. Companies are innovating across the entire system. You've got hybrid cooling systems that are bridging the gap. You've got specialized super energy efficient chips like Tranium that use way less energy. They're even moving backup power from a central room to batteries sitting right on the server racks. Why? To contain any failures, reduce the blast radius, as they say. Every single piece of this puzzle, from the tiniest chip to the building itself, is being completely rethought for AI. Okay, so we have these incredible factories that are building the brains of AI. But what happens next? This is where it gets really exciting. Those brains are now starting to get bodies. And this is the dawn of what we call physical AI. It's the fusion of these powerful AI models with robotics and with advanced sensors. This is all about teaching machines not just to process text and images in the digital world, but to actually see, understand, and act in our physical world. You can really break it down into 3 core pillars, 3 simple ideas. First, you need it to sense. That's using advanced cameras and sensors for vision, basically giving the machine its eyes. Then you need it to act. That's using robotic arms and manipulators as its hands to do things. And finally, tying it all together is the ability to think. That's using those advanced AI models from the factory as a brain so it can make decisions and adapt to new situations it's never seen before. And if you're wondering if this is a big deal, just look at the money. The market for physical AI is on an absolutely explosive growth curve. It's projected to leap from $5 billion today to $50 billion in less than a decade. This is not some niche experiment. This is the next massive wave of industrial and economic transformation. So, deploying this physical AI at a huge scale brings us to the final piece of the puzzle. This new frontier, well, it presents both immense challenges and, of course, some incredible opportunities.
So what does the road ahead actually look like? Well, first, there's sustainability. We have to figure out how to manage the enormous energy and water these AI factories consume. Second, partnerships are going to be key because no single company can build this future all by themselves. Third is the workforce. This is going to create amazing new high-skilled jobs, but it demands a huge investment in education and upskilling. And finally, there's trust. In the physical world, an AI can't just be mostly right. As one expert put it, 85% right is not enough. When a robot is interacting with our world, it needs to be 99.99% reliable.
And this brings us to the final, and maybe the most crucial, question. This new industrial revolution, it isn't just about building smarter machines. It's about fundamentally architecting a different kind of future. And the real question is, are we ready for it?